Thank you for coming, everyone. My name is Stevie Raman. I'm a research scientist at Google. And with me, I have my office mate and co-hacker, Charles Chen. This talk is about accessibility to Web 2.0 applications for all users. And we'll talk a little bit about – I go to my outline slide, Charles. We'll talk a bit about – so the way the talk is structured, we'll talk about what we mean by the word accessibility for the purposes of this talk, and specifically in terms of enabling Web 2.0 applications to be usable by everyone. And by everyone, I mean everyone starting with your grandparents who can probably see perfectly well, but say, that computer, I can't read that screen, all the way to users who are blind, who might be deaf, who might need other forms of special support. This talk is specifically about applications and web applications, so we'll spend a few minutes talking about the context in which web apps are put together, and therefore the technology enablers that we all have at our fingertips in order to enable such widespread accessibility. We'll talk about an open source framework that we as Google released about 6 months ago in the space that Charles and I have been working on. We'll show you code examples. We'll show you demos, the effect of using this framework on a lot of Google properties. We'd like to keep this interactive. If you have questions, you can hold them to the end, or if possible, you can ask it during the talk too. That's fine. Don't just raise your hand and be polite, because I will rudely ignore you. So wave, make noises, do whatever. So the way I usually structure my talks is I make sections out in the talk, because that's how I end up thinking of my talk. So we'll talk, let's go to the first section of this talk, where we'll talk a little bit about accessibility in web applications. So flip to the first slide there. So what exactly do I mean by accessibility? I'm sure those of you who've seen this theme of accessibility and have interest in this field have heard a lot about regulations, that it's a good thing for you to make your applications usable by the widest number of people. But if you look at the space, a lot of the work in terms of saying what accessibility means is often couched in terms of web content and in terms of regulations and fairly high-level concepts, such as make sure that somebody who cannot see color can appreciate your site, or make sure that somebody who cannot use a mouse can use your application. I tend to phrase accessibility slightly differently. If you think of what all of us as web users and web developers do, when we develop web content and we develop web application, the original goal of the web and all the architectural principles that underlie the web dictate that you never ask you never design your thing assuming only a 21-year-old who speaks English and who can see will use your site. If you do that, you are actually shooting yourself in the foot with respect to taking advantage of this wonderful platform that we call the web. The web is a wonderful platform and better than anything that has gone before it because of its reach with respect to the audience you are garnering. And that reach is both global in terms of countries, it's international in terms of languages, it's all age groups, and it's all capabilities. So the way I explain accessibility when I talk about this at Google to the web community, both within and outside Google, is think about it as the long tail of users. So where we as Google excel at the long tail of content in finding you that web page that is the best for you. It might not be the best for anybody else in the world, but you as a user don't care. You as a user care that for the task you are doing, a particular page happens to be the best for you, and we as Google excel at finding that in search. In accessibility, I think of it as we as Google trying to serve each user what is the best thing for that user. So in that context, let's then talk about what accessibility is and what tools users have. So if you look at mainstream user interfaces, your average desktop user interface, your average web interface, if you look at the interface you have to the rest of your world, those user interfaces assume that you have certain abilities, and based on those assumptions, place certain demands on you. So your traditional interface assumes that you can see the screen. When you walk up to this building, that door assumes that you can push it, right? That's the user interface, and that's the set of capabilities it assumes that you have. Now, when there is a gap between those demands that that environment places and the abilities you have, there is a problem. And you typically solve that impedance mismatch by augmentative technology. So I move around with a guide dog. I might use a cane. When I use a computer, I have my computer speak to me. If I have a hearing impairment, I might look at captions. If I have a motion impairment, I might use some other device as input. So that's what you are talking about in terms of bridging this gap for accessibility. Flip to the next slide. So how does all this actually work? So coming down to rubber meets the road, you typically have augmentative software and sometimes augmentative hardware that essentially helps the user bridge this gap. Now, you bridge the gap with speech. You have screen readers for the blind. You have you have self-voicing browsers. You have extensions to browsers that make the browser talk. You have environments that automatically speak applications, all the way down to you have captioning software that allow you to add captions to videos, all of those things. Typically, these things work with hand in hand with APIs on the platform, whether it's Linux, whether it's the Mac, whether it's Windows. So for instance, any of you who have a MacBook, you'll be surprised to know that if you hold the command key and a particular function key at boot up, the Mac will actually come up talking. That's been true since OS X 10. Windows, there are a number of screen readers. There are all of these things. And so typically in the past, when you heard the term web accessibility, you've also heard a few myths that I'd like to dispel before we start talking web applications. So flip to the next slide. So one of the reason why you hear myths about web accessibility, especially for the blind, in terms of, oh, please don't do that on your page. If you do that, a blind user won't use it. In a lot of cases, those are true. But in a lot of cases, there's confusion. So the reason for that confusion is it's useful to understand how this technology evolved. So the web essentially took off just at the time that blind users were coming to handle graphical user interfaces. And the way speech interfaces for the blind were done for the GUI was to say that we will track the focus and speak the thing under the focus. So the web came up at the same time, and as you all know, in 95, the web was about documents. It wasn't about applications. And so a lot of work that went into sort of saying what web developers ought to do focused on this notion of content and a user reading a document by moving focus. And so that's really how the space got defined. And then very silently, starting in 2000, we started adding small pieces of interactivity to the web, where today when you go look at Gmail or Google Reader, those are not documents. Those are full-fledged applications. And one of the reasons why AJAX applications has been a challenge, and that will be the focus of all of this talk, is that when people try to address an application as a document, you end up with significant challenges. These are mostly usability challenges as opposed to accessibility challenges. AJAX applications done right can be just as productive for somebody with a special need as they are for somebody who is a 2020 sighted, mouse-enabled user. And that's really the point I'd like to make during this talk. Flip to the next slide, which is the bridging the gap slide. So what do I mean by bridging the gap? Here is something that I've come to realize in the last 10 years as I worked in the space. So the document is the interface. It's a cliche that we all know from the work at Xerox PARC in the 70s. And it was the motivational theme behind WYSIWYG interfaces, WYSIWYG authoring, and eventually the GUI. The document is the interface. And the web epitomizes this even more by moving away from monolithic applications that, quote, create documents, to a world where you take the piece of information that you're working with and you embed just enough interaction into that information that your user needs at that time. So this is how HTML works. We basically take a document object model, which is the DOM, and we program against it, add little bits of interactivity to it. So the document is the interface at that level. But if you look at the user interface that is realized as a consequence, the user interface is not a document. If anything, the user interface is at best a series or collection of documents. So you go to your Gmail inbox and you do a search, and then you look at the threads of mail about the Google I/O developer conference, right? Now that particular view of your Gmail inbox that you have brought up in that set of what messages are highlighted could be serialized as a document, but the Gmail interface is not a document, and to sort of build good accessibility to it for the blind, to build a good auditory user interface requires us all to think of these things as applications, not documents. Let's flip to the next section of the slide that talks about web applications. And the reason I put this section together was not because people, especially at this conference, you really don't need to say this because all of us are web developers, but it still gives us all a sense of perspective to step back and ask, what is it that led to web applications as they are? And based on those architectural principles, what are the opportunities that we have in order to enable this? So from here on, for the rest of the talk, think web applications and accessibility to user interfaces, and web applications, not documents. So what is the web architecture? The web architecture is a very loosely coupled architecture. So in the 90s, when I used to work in the space of doing good auditory user interfaces for applications, I used to tell software developers, couldn't you separate the visual interface that you do for your application from the actual engine of that application, so that I can then go build a good auditory user interface without rewriting your entire application? Now, in the world of monolithic software that we lived in the 90s on the desktop, this was a very tough ask. People would laugh you out of the room immediately. They'd say, you mean you want us to separate this big lump that we have into two lumps that we don't know how they work together? Go away, right? The web architecture, because it's based on HTTP, HTML, and URLs, with a lot of intelligence living up in the cloud and a fairly thin to a fairly rich user interface delivered into the browser, forced us as software engineers to create that separation. We factored that out. And so today, there is a Gmail interface for mobile. There is a Gmail interface for desktop. Nobody forces you to use the Gmail interface that works on a large screen from a mobile device. If we did, you would go use some other mail service. That tells you something. We have moved from a generation where we built user interfaces that were one-size-fits-all large kitchen sink interfaces to user interfaces that are lightweight, that are agile, and that get delivered to users in the form they want. And that, I believe, is the big opportunity for enabling accessibility to users with different needs that we can leverage. Flip to the next slide. So the other part to keep in mind as we think about how we do this going forward is to step back, understand what all of us as web developers have achieved on the web, and apply those lessons to now what is not just the mainstream but the long tail. The coolest thing about Web 2.0 is not the fact that you can make things animate and jump up and down with a piece of JavaScript. That sort of visual coolness. The cool thing about Web 2.0 is that it's web artifacts built out of what I call web parts. So Web 1.0 was all about us geeks bringing content online. We'd get very excited to see that, oh my God, look, now there's a job search site online. And look, all the weather forecasts are online. Oh, look, New York Times is online. That was about content coming online. And I think of that as Web 1.0. The world of Web 2.0, aggregations and mashups, widgets and gadgets, open social applications, all of these things are no longer simply about bringing a piece of content from the physical world onto the web world. It is about taking things that are already on the web and building new things out of web parts, building them out of HTML, out of CSS, JavaScript, REST APIs, web APIs, things where people give you Atom content, give you JSON content. These are things that are on the web with which we are building web parts. So one of the questions we asked as we put together this open source framework that we'll be talking about is, how do we then build specialized user interfaces out of web parts? How do we enhance web applications using web parts? And so that's really the thrust of this whole talk. Flip to the next slide. So what I want is so the challenge I posed to myself and others in Google engineering when I started at Google about 3 years ago was to say, if you look at what the web community, the AJAX community, has achieved incrementally starting in 2000 all the way up to the first generation AJAX apps with Gmail and then Google Maps later on, we essentially took the browser that started off as something designed for a world of global hypertext documents, and we turned it into a global runtime for highly interactive end-user applications. And we did that with rubber band and chewing gum and paper clips and all of these things. Now we have nicer things like Google Web Toolkit that let you develop these things much more nicely. How can we as engineers use that same level of innovation to enable very good interactive solutions for users who cannot see, for users who cannot hear, and use the web model as opposed to the old desktop model? So the web model to me is all about agile development, developing quickly, using web technologies to deploy it on the web, using the web to garner user feedback, and then iterating quickly where the user doesn't actually have to buy a piece of software every 3 months or every 6 months, where the user doesn't have to do a new install and wipe his disk out, where the user just gets improvement. So that's also what we are looking at in this work, alongside making sure that the AJAX applications that until now have been decried as don't do AJAX apps, it won't work for a blind user, can actually be done such that they work for all users. So having said that, let's sort of talk a little bit about the underpinning technologies that are helping us bridge this gap. Flip to the next section. So if you think of the HTML DOM and JavaScript as the assembly language of the web, I talked briefly earlier about why AJAX applications in the 2004-2005 timeframe proved a significant stumbling block for blind users using adaptive technologies from that era. What happened was, as I said, those technologies treated web pages as documents and knew about the few interactive elements that HTML had in terms of form fields and anchors and select boxes, whatever. But when you write an AJAX app, we do two things. The A is the important part, the asynchronous part, which means that pages are changing under you as you interact with them. Also, we add behavior to what looks like a piece of text through a JavaScript event handler. And the adaptive technology that is just looking at the document as a document doesn't know that what you have is a checkbox or a widget. So sometime in summer of 2003, I think from memory, I and a few others at IBM, at the time I was at IBM Research, we started a piece of work for adding a couple of opcodes, if you will, to the assembly language that is the HTML DOM. So if you think about what you need to discover that a piece of text that has suddenly become a menu is a menu, and if you ask, what do I as a programmer need to be able to figure out that a menu item in a DHTML application is disabled or enabled, right? At a programming language level, this comes down to enabling reflection. And so that's what was added and has today become a specification called the Accessible Rich Internet Application Specification from the W3C. It's called ARIA for short. It's a very simple spec. As specs go, specs are hard to read. So here's your 2-minute tutorial on it. It's basically a set of very simple DOM properties that enable reflection. There's 3 classes of things. There is a role attribute that allows you to ask something, what are you? And it can reply to you saying, I am a checkbox, I am a pull down, I am a tree control. There are dynamic properties that tell you the state of something. Is this button pressed? Is this menu open? Is this menu item disabled? And there is the ability to set up observer-observable relations using a mechanism called live regions. What that does is that, say you have, you create a classic mail application where you're showing 2 panes. One pane is showing a summary of your inbox, and the other pane is showing the thread that you currently have open. And then as you move your selector in the summary pane, the message that is being displayed in the right pane changes. So basically, you need to know that there is an observer-observable relationship between these two panes if you are going to be able to write software that speaks that updated message in the right pane. So that's what live regions do. This technology is now being implemented in pretty much all the browsers. Firefox was the first to implement it. Opera followed. WebKit just started implementing it, and IE8 in its beta has announced an early implementation. So there's fairly full coverage. Flip to the next slide. So the ARIA opcodes that I mentioned give us as web developers a leg to stand on with respect to communicating all the coolness in our web applications to various adaptive technologies. But if you think about it, so let's say you go write your cool music sharing app. A user who comes to your site doesn't come for the pleasure of checking a checkbox, right? The user comes there to use your application. So though something like ARIA is needed for making sure that all the basic widgetry in a GUI application that's done as a web app work correctly with adaptive technology, that is not enough. So as an engineer would say, that's a necessary condition, it's not a sufficient condition. The sufficiency condition is actually what I call building usable UI. And so at this point, we are back to talking usability as opposed to just users with special needs. A usable UI is one that enables your users to use the application end to end. And there is this very difficult to quantify thing, which is at the end of the day, they are happy. And the sort of happiness is something that we at Google focus on a lot in terms of users being happy. It's not a tangible thing, but it makes a huge difference in how many users come and use your thing. I mean, Apple always had the same thing in terms of it gives you pleasure to use their devices. And I believe there is a similar happiness factor with web applications that come from it just worked. I got my job done. It is not glitch that makes you happy. It's when things work that you get happy. So flip to the next slide. So in all my experience of doing good auditory user interfaces, there are about 5 categories of things that you do in order to make sure that an application works really well when you're not looking at the screen. And by the way, a lot of these things are actually useful for power users as well. So when you look at this category of things that I'm enumerating, they're not just for special needs users. They'll really help your power users as well. So the first among these is sort of an obvious one that everybody in the accessibility field tells you, which is make sure that all your visual elements have good metadata associated with them. So people tell you that, but unfortunately they stop there. So that's not enough though. That's sort of a starter. The next thing you need to do is to ensure that all user actions produce appropriate feedback. This again sounds like a no-brainer from a usability perspective. The reason it's important to reiterate this from a blind user's perspective is that often that confirmation, the fact that I deleted this mail message, the deletion happened, is usually indicated by just a visual change. And we need to make sure that the right AJAX DOM bits are used so that somebody who is using speech output gets the right notifications. The next bit is actually quite interesting, which is if you think about how a complex visual layout works for you, it works because your eye gets random access to different parts of that display. So, and we'll demonstrate all of this with very concrete examples very soon when you start showing your code. But think about how you look at a railway timetable. Think about how you look at a bus timetable. Think about how you look at a stock chart. You never read those things like documents. You do not read them left to right, top to down. In fact, what happens is you actually look at them. They essentially function as a mini database. So there's all this information sitting on the screen, and your eye essentially does a quick query where it says, what is Google stock at right now? Or I need to be at Moscone at 9 in the morning. When's the train from Mountain View leaving that gets in at 9? Oh yeah, there's a train getting in at 8:50. When does it leave Mountain View? And then you say, that's the train I'm taking, right? So this is something you absolutely have to enable in order to build a user interface that actually works for somebody who's using an eyes-free interface, as opposed to, it's sort of just, okay, you can muddle your way through it. And guess what? What I just said applies to a cell phone as well, because you don't have a big screen. The whole timetable doesn't fit. How are you going to use that train timetable on your cell phone? You're going to search. And then finally, there's getting to different pieces of the page with the keyboard rather than relying on random access with the mouse and pointing like that. So that's the category of 5 things we do. So flip to the next slide. So about October of 2007 last year, Charles and I started a framework called AxsJAX. We came up with this name saying AJAX, and we wanted to inject accessibility support into AJAX applications without disrupting how those applications were done. So one fine morning over a good Google breakfast, he and I doodled on a paper napkin and came up with a logo that Charles can model for you. So the idea is that we said there is this car called Web 2.0 that's on the move, which is powered by AJAX. And if you're driving a car and you need to keep moving and need to do a quick fix, you jack it up and push something under it. So we put the XS under it. So the goal of the AxsJAX framework is really to protect, insulate, abstract the web developer from the minutiae of the couple of opcodes in the DOM that I talked about, but let you as the web developer focus on when the user deletes a mail message in my web app, I would like whatever adaptive technology he is using to say message deleted. This sounds like a no-brainer, but this is again a hard problem, because the screen readers that various users use, each of them do not actually give you, the developer, an API that says speak the string. They basically say you put it on the screen, we will talk. Which means that as an application developer, you are sort of down in this write once, debug everywhere model, where you write your code and then if you actually are paying attention to the issue, then you're running one screen reader and saying, oh, that screen reader said that, it worked. And then go to another screen reader, it doesn't say the same thing. And screen readers are expensive. So this whole thing, basically, web developers throw up their hands and say, it's too painful. I'd like to do the right thing. Tell me what, we'll do it. And then if you throw lots of guidelines at them that are all content-based, then the consequence is what we saw in 2005, 2006. All the AJAX apps were completely unusable, if you couldn't see. So what we have done is we are doing 2 things in the AxsJAX framework. One is to abstract out details of the ARIA spec. By building on ARIA, the browsers are implementing ARIA, the screen readers are implementing support for ARIA. But we are giving you as the web developer, and not just you, us as web developers as well, because Charles and I have been using our own framework to build the things we'll show you. We are giving ourselves higher level calls that allow us to, in JavaScript, say, speak this DOM node, or speak this piece of text, without worrying about, is it on the screen, and should I tell the screen reader, go read, the contents that is in the top left corner or something like that. The other thing we are doing with this framework is what I said earlier about how web development works, which is it's all about agile development, deploying it on the web, using web technologies to deploy, iterate, and improve. So we open sourced this framework in October, and all of the code is checked into the Google Code project, and these slides have a link to that you will see. Basically, just search for AxsJAX on Google and you'll find it. One of the advantages we got out in this project that is actually quite nice with respect to distributing software using the web is that because it's checked into Google Code, all of this code is basically what I call URI addressable. Simple fact, right? Google Code uses Subversion. Subversion is accessible via HTTP. Each of those things are no-brainers. But when Charles and I check in code, each of these scripts have a URL, and we inject these scripts into applications when we are prototyping through GreaseMonkey, which is another wonderful piece of software. So if you connect the dots, you connect Google Code, you connect SVN, you connect JavaScript scripts checked into this SVN repository that are available via HTTP URLs, and then you connect up GreaseMonkey, you suddenly get this prototyping environment where Charles and I can check in an improvement to a script, and our end users get it immediately. And then what we do in the spirit of agile development is that as our scripts get robust, get user feedback, and things work, then we go back and check it into the main code repository for whatever app that we are extending. And then basically from the external, we leave the code on Code Google.com so that developers can study how we did this. And then we basically pull out the grease monkey loading magic for that particular app, and everything continues to work. So the lesson is insulate your users from the fact that today you are in development mode, tomorrow you're stable, but get the advantage of what you have built to the users as quickly as possible, because there's no point in me and Charles building this in our office and waiting for a year for it to get perfect and then give it to the users, because the users need it now. And what we've learned, and I know this firsthand, is that users need these solutions badly enough right now that they would rather have it as you're building it and use it and give you feedback, rather than you sort of saying, I know best, I will develop it in secret and then give it to you a year later. So we'll start showing you some demos and code right now. So the first set of demos and examples I'd like to talk about is in the context of Google Web Search. Now, Web Search, today we use a few AJAX bits in Web Search for enabling some features. But traditionally, nobody ever thought of the results page as an AJAX application. In fact, our results page still works in down-level browsers like Lynx today. But what I'd like to show you as we sort of go through the set of slides and show you the code running is that by using AJAX in conjunction with the AxsJAX framework that gives you all the goodness of ARIA under the hoods, you can actually significantly enhance the user experience for something that is very content-rich, like the Google Web Search results page. And the user experience that you get as a blind user or as a low vision user with this, you would never go back to using a document-oriented interface, which was what everybody was using until we sort of did this work. So the code that I'll show you does all of those things that I talked about. The Google results page is a very rich page. When you do a result search for flowers or something like that, you see ads, which depending on what you are doing are extremely useful. So for instance, if I'm shopping for something, I often go look at the Google ads because the ads are actually much easier to read than something on the manufacturer's website, which is a lot busier typically. If I'm doing research on something, then I want to go look at the search results versus the ads. If I want help in rephrasing my query, then I want to look at all the related searches that Google puts up. If the first set of 10 results doesn't contain the answer, which fortunately given our search quality is rare but does happen, I want to go to the next page of results. As a blind user, I don't care that it's the next page of results. I just want the 11th result. I don't want to get a fresh page and then go hunting in it for the first result again. When I do a search from a good auditory user interface point of view, I just want the first result spoken. Again, from an auditory user interface point of view, that result as it is displayed has a lot of things in it. It has the main title of the result. It has a snippet, which is a body of text about the result. It has a bunch of links. What is the most common action that you do when you have that result? You hit enter and you go to that site. I want that. So let's bring up our demos here and we'll talk through this. I'll let Charles do a bit of talking so that I can drink some water. And we'll also show you some code snippets.
Okay. So I'm going to turn on the speaker and do a search for flowers. So I've typed in flowers into the search field. I'm going to do a search, and you'll see that what happens next is exactly as Raman had described earlier.
Flowers, roses, plants.
So notice how when that search result, page of results came up, the first result was spoken. And you also notice that it magnified the text there. But it didn't magnify the whole screen. It just magnified the one result that the user is interested in. Now, if I want to proceed to the next result, rather than trying to scramble around and find where the next result starts, I can hit a single key and get to the next result. So I'm going to do that right now.
Flowers, plants, roses, and
And so you see it just went on to the next result. Now, if you keep on going and you reach the last result of this page, why should the user have to dig around and find the link for the next page? To them, it should be as simple as just going to the next result. And the logical thing to do at that point would be to take them to the next page and read the first result to them. So I'm going to do that now. And I'm going to be going pretty quickly so we can get through this. So this will flush the speech.
Send flowers vineyard. Emily Simon flowers.
And notice how now it loaded up the next page for me, and it read the first result. Now,
the secret of building a good auditory interface is that you should also learn to stop the speech immediately, quickly. And notice how quickly that speech flushed there. That's important.
Yes, silence is golden. Now, the other thing is, as Raman had mentioned, sometimes you actually want to see sponsored links or related searches and not the main result set. And so we can do that as well with, again, a single key press. So I'm going to go through the sponsored links right now.
Free delivery FTD same day flowers deliver flowers get.
So I can do that. And if you're wondering how the user can discover these keys, we've kept to a convention of letting them type the question mark and always hearing us the available keys.
The following shortcut keys are available. Down J, cycle back.
And so it will keep going.
So there are two things I'd like to sort of describe in this context. One is the end user's mental model, and the other, which is the web developer's mental model, so that all of you as web developers, when you sort of look at a complex web page and think of the AxsJAX framework, can sort of understand what you do. So let me first talk about the end user's model. The end user's model is that at any given point, you can do a set of things based on where you are, and you discover that by hitting the question mark. You discover the things you can do, and those things that you can do typically walk you through the contents on a page, such as moving from result to result, or moving from add to add, or moving from search refinement to search refinement. That's the end user's mental model. Notice that this sort of matches what we as web developers have always striven for the mainstream user who can see. So you go through a lot of trouble in terms of building your DOM and building your CSS so that the human eye can do what I just said, which is either move from result to result, or jump to the ads, or jump to the various search refinements. That's the end user model. How do you do this as web developers? The way you do this as web developers in the AxsJAX framework is to leverage a piece of software we wrote in the framework called AccessNav. What the AccessNav module does is it takes from you a declarative representation of how you want to be able to have the user navigate that page. And the way you should think of this as developers is that if you think of that big complex DOM that you have built and laid out, that's a collection of nodes. Think of there being many logical trails or hiking paths or whatever you want to call it through that DOM. So in the case of Google results, as you saw, one interesting trail is one where you walk along all the results. Another interesting trail is one where you walk along the sponsored links. And it's useful to know what trails there are on a page. So if you look at that fragment of XML that Charles is showing from our code repository, what we do is we declare in this fairly simple XML thing that we cooked up. This can be XML, this can be JSON. It's basically a piece of declarative data that was factored out of our code after we wrote the first few examples, and then sort of stepped back and stared at it to see what we had done as software engineers. So in that declarative format, you basically say, here are the trails in my page. You basically use XPath to identify the node sets that make up those trails. You say what keys you want to use as forward/back keys for moving on that trail. And optionally, you can specify what action you want executed when your user moves through that trail. That's your classic visitor pattern. So notice that by just doing that, by defining this what we call them a CNR file for content navigation roles, by just defining that, the AxsJAX framework actually does a lot of the work for you. So for an application like Google Web Search, most of the work was actually done in that CNR file. Now, at this point, you can basically extrapolate to many, many content-rich sites on the web that can leverage this. Everything from the New York Times to CNN to Wikipedia to Gmail to a lot of things, right? And so if you look at the Google code repository for AxsJAX, you will see that we have scripts for Gmail, we have scripts for Google Reader, we have things for Google Books. We've done a whole slew of things. And what is happening as we go through these is that as these things get stable and ready for broader deployment, they basically go back into the product. So I'd like to spend some time talking about Google Reader, which is one of my favorite AJAX applications, and one of the first things that I actually voluntarily did inside the browser, that other than browsing web pages, simply because it is such a well-done application. So for those of you who have not used Google Reader, it's a very good feed reader, and the amount of things you read once you use Google Reader goes up by an order of magnitude. It is a power user application, which means that a lot of functionality in that application, all of that functionality, in fact, are actually driven from the keyboard. You can use the mouse, but believe me, you will be more efficient if you use the keyboard. Everything is keyboard driven. You subscribe to a bunch of feeds, you browse through your feeds, you open a feed, you browse through articles, and you go bang, bang, bang. And it's gears enabled, it has offline storage, all of that wonderful stuff. So Charles and I used the AxsJAX framework in last fall, so October, November last year, to add in sort of a good auditory user interface to it, and then we integrated that support into the application in March, and it's a shipped thing now. What we'd like to show you is what it feels like to interact with Google Reader that is AxsJAX enabled, and you will see a lot of what I was talking about earlier with respect to, as a web developer, audio, speech enabling, voice enabling, access enabling your app without worrying about the adaptive technology, and yet having it work completely seamlessly with adaptive technology. See, at the end of the day, this is what standards give you, and this is why having ARIA as a standard that is implemented by the browsers, by the adaptive technology vendors, and used by us as web app developers gives you. What we are then doing is building a high-level abstraction over it, as I said, and so things like the Google Reader can just say, speak this text, and it speaks it. So let's go to Google Reader.
Okay, so I'm going to bring up Google Reader, and I'm going to activate the version that has the support in it.
Click here for ARIA Enhanced Google Reader.
Okay, so I'm going to activate that.
GK 850. GK 8.
So now notice that what happens is it speaks where the visual highlight is. So first off, I'm actually going to make the highlight a little bit larger and more visible. So now you see that it's enlarging the area that I'm highlighting. And as I navigate through that with the reader hotkeys, you'll see that it's reading where I'm at. So
Cool Tools 28.
Okay, so I'm going to open the official Google blog.
Life make penny arc Google's John Patel official Google blog 18.
Okay, now I'm going to open this feed and show the articles.
Articles loaded.
Now notice that it just said articles loaded right there. That text is nowhere on the screen. However, through AxsJAX, by issuing a speak text call, it causes the assistive technology to say that, even though it's not displayed. Well, that information isn't needed for a sighted user who's looking at the screen and can just visually tell that the page is loaded. It's important to provide that auditory feedback for a user who's just doing an audio interface and who's only listening to the page.
So this is an interesting bridging technology that we've built, which is traditionally screen readers, as the name implies, read what's on the screen. Now, often putting information on the screen just so a screen reader reads it to somebody who cannot see detracts from the mainstream UI that you're building, because as Charles pointed out, you can see that the article's open. There's no point in wasting screen real estate saying articles loaded. So this has been an interesting challenge in the past. It's been a challenge even in the case of desktop applications. And one of the neat things that is there in the AxsJAX framework is this ability to use the DOM and then trigger speech feedback from the adaptive technologies. So whatever deep dark magic is involved between DOM opcodes and screen reader implementations is abstracted away from you. And we've done the testing to make sure that it works with all the shipping screen readers. So you make your call and it works. You want to show a couple more things over here?
Yeah, so we're going to go ahead and just show that it can read articles as well. So
9:45 a.m., 3 hours ago. Happy birthday, Google Gears.
So you can just use the hotkeys again to go for
May
the articles.
27, 2008, yesterday. Many here, many do from official Google blog.
And so by doing this, you have access to all the functionality of Google Reader, and you can just hear it.
Shall we do in translation?
Yes.
Okay.
Let's go ahead.
So while Charles brings up the next demo, this is something interesting in terms of building web solutions out of web parts. So for us at Google, as everybody has been stressing at this conference, the web is the platform, and we do lots of cool technologies. So one cool Google technology is Google Translation, which I'm sure many of you have seen, especially on the results page where we say translate this link. That same translation technology about 6 months ago, I believe, sometime last December, became available to Google Talk users via chatbots. So now you can invite this chat buddy, who is a bot, and you type at him in English, and he will type back at you in the language of your choice. So there are bots for each of the language translations that we support. So that's the next piece, right? So now, where is the chatbot most useful? The chatbot is most useful in two contexts: when you are chatting with somebody whose native language you don't speak, or when you are doing email. And email and chat sort of go so well hand in hand that those two things are integrated in the Gmail interface. So in December, January, Charles and I used the AxsJAX framework to make the Gmail interface work fluently. So then we had that. So now we had Gmail talking through all the screen readers, self-voicing browsers using the underlying ARIA magic. Gmail, because it's a power user app, again, everything can be done from the keyboard, so we didn't even have to add keyboard support. So now let's put the pieces together. You have Gmail, you have chat, you have translation, and we had speech output. Suddenly you sort of connect the dots. This thing turns into your friendly neighborhood interpreter that comes along for free and translates for you from one language to another, and not just translates by showing you the text on the screen, it speaks it. So let's do the demo.
Okay. So right now I'm in Gmail, and I'm going to go to the chat area and start chatting with the bot. So
One human.
Okay.
Less than n2chatbot.talk.google.com greater than online. New chat message from n2. Press escape to ignore the message. Press any other key to open a chat window. Mail.
Okay, so now I've loaded up a chat window with the translation bot, and I'm going to type a message to it. Okay, and we'll see what it says.
Welcome to
欢迎到 San Francisco.
So as you can see, it translates that and it speaks it.
So it's an interesting. It goes back to Web 2.0 is all about building web things out of web parts, and in this case, Google has built a bunch of interesting pieces that are all exposed as web parts, namely Gmail, namely Google Talk, namely translation, and chatbots. And what the AxsJAX framework has done is it's added to this mix a web block that allows you to speech enable, access enable web applications. And so when you take that block in with the rest of the pile and do what we as web developers do, which is mash them up, you get a talking interpreter which if I told you up front, can you develop me a talking interpreter as a web application, sounds like a daunting task. But by standing on one another's shoulders as opposed to one another's toes, you sort of get a very powerful infrastructure for doing such things. We have about 10 minutes. We can do more demos or we can take questions. So if there are people who have questions, raise your hands. Otherwise, we'll show you a few more demos and code.
Okay. No questions right now.
Yeah. So there's a question about?
No questions.
Okay. So we'll show you another interesting mashup, which is the XKCD comic. This is an interesting example of, again, bringing information from different parts of the web to form an integrated whole that doesn't exist. So for those of you who are familiar with Randall's XKCD comic, and for those of you who aren't, since most of you are web developers, I suggest do a Google search. It's a comic strip you will highly enjoy as somebody who's likes technology, and you're probably a geek. If you're a geek, you'll love XKCD. So the XKCD comic, Randall has these very nice sketches and a small caption that goes with the comic. It is enough as a caption if you can also see the sketch. A more detailed textual description there would actually be very nice for a blind user, but would actually detract from the value of the comic for everybody else. Now, there is another task on the web that needs a full transcript of that comic, namely search. And there is a completely separate site that is independent of XKCD and all the other comics. That is a comic bot search engine, where volunteers go in and type in detailed transcripts of comic episodes. And then the author of the comic goes and approves them, and then they become live. And then there's the search engine that allows you to search it. Now, we looked at this and we said, you know what? As an end user, since both the transcripts and the comic are on the web, you can clearly, if you have the time and patience, go open a comic, look up its ID, then go look up the transcript for that comic strip in that other engine, and then go read it. It's too much work, right? Good programmer is a lazy programmer, and we all like reading comics. So we basically built a mashup that essentially pulls the transcript of the comic that you have open from this other site, and then uses the AXsJAX framework to speak it. And so suddenly you get XKCD becoming a talking comic with transcripts coming off the web, which is another example of building a web thing out of web parts.
Okay. So I'm going to load up this XKCD comic, and we'll see what happens.
XK sandwich transcript. A man is sitting on a couch, talking to another man. They are both stick figures. First man, make me a sandwich. Second man, what? Make it yourself. First man, sudo make me a sandwich. Second man, okay. Comment. Proper user policy apparently means Simon says.
So we could all say sudo make me lunch and get lunch soon, I guess, or sudo extend lunch until 2:30. So we had a couple of announcements to make from the organizers. Lunch has been extended to 2:30. Somebody must have said sudo postpone lunch. And the other thing was there are evaluation forms that we would like you to fill up so we get some feedback on the session. That's pretty much what we have. We have about 6-7 minutes for questions. Otherwise, we can get an early lunch.
Oh, yes, you there.
You've shown us a lot of examples of spoken and written languages. Are you doing anything with sign languages?
So the question was about whether or not we're doing anything with sign languages.
Yes. So for the video, the question was, we are doing a lot with written and spoken. Are we doing anything with sign language? Right now, we aren't, but I would love to see work in that space. If you have expertise in that space, we would love to see some open source developments in that space. As I said, the AxsJAX framework itself is not limited to speech or written language. Today it has calls in it for speech because that's what we've built. The way we are building this framework, and every line of code in this framework has been written this way, is to first build a real prototype, build a prototype, and then build a second prototype, and then see what commonality is there between those two, and then refactor it and pull the common code into a framework. So not a single line of code in this framework has been written because we thought it was a good idea to have it in a framework. It was because we saw ourselves writing that same piece of code again and again. And I would love to see similar things for sign language emerge. I clearly I don't have much expertise in that space, but and I'm sure and clearly there are many people in the world who have expertise in that space. So it would be nice to see.
Yes, and if you contribute any code to AxsJAX, we do have a strong policy of rewarding everyone who does that with AxsJAX shirt, much like this one.
Cool. Do you have any insights on how to make geographic information in the form of maps more accessible or usable? I work with transit data, and oftentimes transit providers will just create a whole new, they'll create a long textual description of the route, but if there was a way of using the Google Maps API for those instructions, it would be cool.
So you were using a mic, so I suspect the video got the question, but the brief summary was thoughts on making geographic data and transit data more usable in an ICE-free environment. There are a bunch of things you can do. My current favorite is actually to go pull the KML file for a route and then extract a good spoken description out of it. That actually works remarkably well. There are other things you can do with the JavaScript layer and using the Maps API. For instance, the kind of lens demo that we showed you would be a very interesting thing to do in the context of maps for a low vision user. From a blind user's perspective, I haven't seen anything better yet than sort of going step by step through the textual directions. It would be nice to do something with tactile displays, but tactile displays are enormously expensive. To give all of you a little bit of context in that space, unfortunately, the only tactile displays that really exist out there are sort of dynamic braille displays, and they tend to be very expensive. So I was at an accessibility conference about 5 months ago, and they were showing a tactile display that was a grid of pins that was, about 360 by 240 pins that they wanted a cool $20,000 for. That's too much. So the issue, there's two issues with respect to the geographical data / information, which is what kind of queries do you as an end user make out of such information, and then how do I give you the answers to those queries. So the display part is both, in some sense, if you think about it as a tactile display, it's both about answering the questions about what is here on this map, as well as giving me an interface for posing the question, which is I go touch a part of the map and ask what is there. Now, given that tactile display technology is expensive, my view of building innovative solutions in the space is to actually give the user the ability to query intelligently. So the reason why I like the KML handle into Google Maps is that I can do a query of the form pizza near my home address, and then go look at that, and then ask for textual directions from there, and then ask what is near that. Which, if you think about it, if I show you a graphical map, that is what often your eye is doing. There are other things that your eye is doing with things like street view, such as saying, I am now facing the Moscone Center, and oh, that building is over to the right, I need to go that way. That I don't have an answer for yet for myself. I would love to have that.
How do you extract the textual data from the KML file?
I wrote an XSLT transformation.
Oh, wow.
So that is actually checked into my other open source project, which is Emacs-Speak. It's a talking extension to Emacs. So if you just Google for Emacs-Speak, it's Emacs-Speak with one S. You will find a pointer to it. It's also checked into Google Code. And if you're just interested in the textual directions out of the KML file, again, it's checked into SVN, so there's a URL for it. You can just look at that XSLT file in your browser and look at it. It's very easy to do. So you basically take your maps, go do a traditional search on Google Maps, and then add output equal KML as a CGI parameter, and it'll serve up a KML file. And KML is fully documented on the Code Google.com site. It has a lot of useful information in it, including heading and all of these things. But for extracting textual directions, I've already written the XSLT, so you can just steal it.
and we're done.
Thank you.
Okay. Oh, and if anyone's interested in trying to develop with this, we do have a limited supply of CDs. So just catch us now or later on in the hall, and if we still have some, we'll give them to you.
I mean, as I said, all of the code for the AxsJAX framework is on the website, but what we have on the CD is a standalone Firefox that has been configured to talk. So you can experiment with it without actually changing your default Firefox profile.